Good morning, all. I, Dr. Sharvari Tamane, working as a professor and head of University Department of Information and Communication Technology at MGM University, Aurangabad. I would like to thank the World Resources Webinar team organizers for giving me the opportunity to share my knowledge as a resource person in the UMK workshop on topic Big Data and Automation in Animal Husbandry. Thank you once again, organizers. I'll start my presentation. So these are the table of contents of my presentation. I'll start with the introduction to animal husbandry. So a large number of farmers in India depend on animal husbandry for their livelihood. In addition to supplying milk, meat, eggs, wools, and hides, animals, mainly bullocks, are the major source of power for both farmers and dairies. Thus, animal husbandry plays a key role in the rural economy. The growing demand for food and advancements in sensing technology have the potential to make animal farming more centralized, large scale, and efficient. It has the potential to change animal farming. With the help of sensor technologies, farmers can produce more meat and animal products, but with some challenges, which we will see in further slides, along with the role of sensors, big data, artificial intelligence, and machine learning in helping animal farmers to lower production costs, increase efficiencies, enhance animal welfare, and grow more animal per hectare. In our modern world, many sources of big data can be identified, such as the data incoming from measuring devices, events from radio frequency identifiers, streams of messages from social media, meteorological data, earth remote sensing data, information from audio and video recording devices. And according to the different studies, investments in IoT technologies will reach $1 trillion by the end of 2022, which is a clear indicator that the number of smart and connected devices will grow. At the same time, the number of devices and sensors that collect and transmit data will grow exponentially. As a result, the flow of information generated by these connected devices will also grow. Big data technologies include more than just analyzing massive amounts of information, and the problem faced is not the quick growth of data volumes, but the format in which they are represented. Because that doesn't correspond to the traditional structured database format, which includes blogs, video recordings, text documents, machine language, or the geospatial data also. The information is generally stored in many different repositories or data processing centers, sometimes in other countries or external organizations also. As a result, users may have big volumes of data without having the necessary tools to organize, classify, group, and establish correlations between the different information that lead to meaningful conclusions. Historically, animal farming has always been decentralized on a scale that a few individuals can get together and manage. And until a decade ago, most animal farmers did not have the access to modern technologies such as high-speed internet, smartphones, and cheap computing power. And both these conditions are changing very rapidly. So the global demand for various meat and animal products is set to increase by over 70% in the next 3 decades. So we know that globally, wherever populations and incomes have risen, meat consumptions have also increased. And this means that we now need to produce more animals with a limited amount of land, water, and other natural resources. Then we also require that more than half the global population is connected to the internet, either through smartphones or computers. Cheap phones that can be carried in our pockets have greater computation power than the computers on Apollo 11, that is the first crewed spacecraft to land on the moon. So this means that computing power is now easily accessible by millions of animal farmers. So it is estimated that farmers need to increase production by 70% over the next 50 years to meet the growing global demands of meat and animal products. Since land and other natural resources are limited, to meet this growing demand, we'll need to find more efficient ways of growing more animals per hectare. This also means that manual processes of animal farming may no longer be sufficient. It also means that we need to find ways and systems that help us achieve greater gains in animal farming. And today's technologies such as different computers, sensors, cloud computing, machine algorithms, machine learning, artificial intelligence are already transforming several industries. They create greater gains and efficiencies. This is why we need to explore how these advanced technologies can help us achieve greater efficiencies and gains in animal farming. The primary cost driver in animal farming is stocking rate, defined as the number of animals grazing on a given amount of land for a specified time. In addition to this, as any farmer will tell you, two major costs in animal farming, which are feed and disease management. So due to economies of scale, farmers can optimize their major costs and lower their production cost by increasing the number of animals they stock in a system. However, most animal farming practices need manual interventions at some level. People assess feed rates, identify and treat diseases, and take care of production. So this places limits on how many animals can be cared for. So if your people can take care of many more animals, this will remove the biggest bottleneck in increasing production as well as profits. Then the third part, that is the models, sensors, big data, and advanced algorithms. So we can use these models to elucidate causality in complex systems. A model should be able to provide an explanation for the patterns of a system under study. And this approach is most useful in solving complex problems that have several variables. So this means the problem cannot be solved by mere experimentation alone. Instead, solving such a complex problems needs systematic collection and analysis of large volumes of data. So in animal farming, these models have the potential to solve complex problems such as identifying the functional limiting factors, determining optimal nutrient composition of animal feed, evaluating animal management to evaluate performance, examining strategies to reduce nutrient excretion into the environment, and forecasting outcomes in other completely new scenarios. So to apply these models in animal farming, we need to collect a large volume of diverse data sets. For example, local weather data, air quality data, voice signals of animals, visual data of various animal movements, and other such animal behavioral data. So based on the animal farming, market needs the sensor technologies which can be classified into different types like sensors for precision milking robots and feeding systems, application based on species like poultry, ruminant, swine, etc., and hardware sensors such as camera or vision sensors, infrared thermal imaging sensors, temperature sensors, RFID tags, accelerometer, motion sensors, pedometers, facial recognition machine vision sensors, or microphones like this. So the big data plays a key role in applying different advanced technologies to animal farming practices and offers a scalable solution to store vast amounts of data on a remote server. So these advanced AI ML algorithms can make use of these extensive data to analyze, predict, and notify farmers in case there is something abnormal. So therefore, in the context of animal farming, sensors, big data, and advanced AI and ML algorithms may be referred as advanced technologies. And it will help us to find different ways to optimize performance, understanding complex systems, recognizing complex patterns, and predictive abilities. So we'll see this in detail. So in practice, these advanced technologies can be used to determine optimal solutions to many animal farming problems. A few examples include finding optimal solutions to minimize costs, maximize production, increase efficiencies, and create optimal diet formulations. These advanced models may even consider variables such as genetics, environment, and management priorities in order to come up with relevant and contextually optimal solutions. And in general, the more diverse data sets a system collects and analyzes, the better are its chances of arriving at accurate and optimal solutions. So such a solution will also have the advantage of providing farmers an evidence-based or data-driven solution. Advanced technologies can provide the opportunities to explore how complex systems like biological systems works, and it can also help to extract meaningful information from data and increase our ability to understand complex animal systems. They can help to compile experimental data and derive meaningful parameters like deriving fractional rates of rumen degradation or clear-cut rates memory cell proliferation. So, but these advanced technologies are not exempt from failing. In fact, they are exceptional tools for determining areas where scientific knowledge is inadequate or where an assumption on the regulation of a system may be incorrect. Broadly, these advanced technologies excel at interpreting various types of data such as text, audio, videos, and images. Advanced algorithms can then cluster, classify, or predict patterns within such data sets. And within animal production systems, pattern recognition through advanced data analysis and algorithms have been applied to the detection of disease and monitoring of animals. For example, a range of sensors along with big data and machine learning models have been developed to evaluate changes in animal behavior, which may imply or represent a change in the heat, injury, metabolic state, or health status, or are used for animal identification also. So different sensors are used to classify animal behavior such as resting, ruminating, grazing, and walking. There are different predictive abilities. This leads to ability of advanced technologies to forecast and predict outcomes of economic importance such as body weight, milk, yield, or egg production. Um, Typically, the farmers address diseases in their animals by either taking no action or proactively using different veterinary doctors or using a mix of antibiotics or in many cases by taking a combination of these three approaches. So the modern technologies such as sensors, big data, AI and ML present a new possibility to farmers. So instead of reacting to diseases after they became evident or proactively using the services of doctors, it provides an opportunity to constantly monitor key animal health parameters such as movement, air quality, and consumption of food and fluids. So, by constantly collecting this data and using advanced artificial intelligence and machine learning algorithms to predict deviations or abnormalities, farmers can identify, predict, and prevent disease outbreaks even before a large scale outbreak. So, in other words, sensors can constantly monitor animal health instead of humans. And such a system has different benefits. For example, such a system can enable fewer farmers to care for many more animals, in turn, lowering production costs. Second, maybe such a system can notify farmers about the possibility of a disease even during the preclinical stage. And this will in turn help farmers take timely action to prevent catastrophic losses. So, a continuous or a contagious disease outbreak can cause severe losses in a large animal farm where thousands of animals are sheltered together. So, in such a setting, the contagious disease outbreak will be hard to contain unless the farmer take timely or early interventions. It is already too late to intervene once the symptoms become evident. Left unchecked, a disease will spread rapidly, resulting in a combination of animal deaths, poorer health, and financial losses. And on the other hand, a smart farm with several sensors may notify the farmer about abnormal animal behaviors at much earlier stage. Um, for interpreting the data using the different machine learning algorithms is having the big application in dairy farming. Automated systems excel at collecting, processing, and analyzing large volumes of data quickly. They cannot make effective decisions without data. They can assist humans in making better decisions when they collect and process large amounts of exhaustive data. And different sensors can help farmers track animal behaviors in real time on a farm. And the advanced algorithms can make the use of big data to track, quantify, and understand animal behavior changes. In turn, this can help the farmers make better decisions and perform timely disease interventions. So today there are several sensors available that can help farmers track changes in animal movements, food intake, sleep cycles, and even air quality in animal shelters. So this raw data is first stored and processed into a computer that is capable of handling big data. And finally, the machine learning algorithms highlight any variances or deviations from standard patterns. So sensors, big data, and machine learning algorithms have been employed to successfully diagnose the early onset of several diseases that affect pigs and sheep based on the lethargic body movements, slower response times, and decreased activity before the onset of other noticeable disease symptoms. However, in a large herd among several animals, it is hard for farmers to spot these changes with the naked human eye. The air sensors in the poultry industry can predict the onset of coccidiosis, an intestinal infection that can spread quickly among birds without any apparent symptoms. One way to identify this disease is by constantly monitoring air quality and the concentration of volatile organic compounds in the air increase as the number of infected birds increase. So air sensors can detect this change much earlier than a farmer or doctor could. The alerted farmers can then take timely measures to prevent further spread of the infection. Such a system saves several animal lives and prevents financial losses. Then it is also equally hard for a farmer or caretaker to spot changes in feeding habits, fluid intake, and unusual body movements or sick animal among a large herd of animals. And this is where sensors, big data, and machine learning can play an essential role in helping farmers become aware of such abnormal behaviors, thereby promptly predicting and preventing disease outbreaks. So, similarly, among larger animals, sensors, big data, and advanced algorithm can predict several diseases much better than the humans can ever hope to do. So, for instance, cows affected by mastitis and other disease end up producing low quality and quantities of milk. So, conventionally, to diagnose mastitis, somatic cell counts and electric conductivity readings are taken manually. And these manual readings can often turn out to be unreliable, unsteady, and not useful. Instead, automated sensors and algorithms can reliably collect, predict, and reduce the risk of mastitis in cows. The early disease detection methods were costly and could not be adopted at scale. Today, the sensors, big data, and machine learning algorithms have a significant cost advantage over these methods, and at a fraction of cost, they can quickly predict and prevent a contagious disease. And more importantly, advanced technology can now predict many infectious diseases before they spread on a large scale. There are different big data analysis methods. For example, data mining, which is a set of methods used to identify the most receptive consumers to a certain promoted product or service, or the characteristics of most successful employees. It is also helpful when it comes to consumer behavior prediction. Second is the pattern recognition, a set of methods using self-learning elements to predict consumer behavior patterns. Then spatial analysis. It is a method used to analyze the spatial data, partially based on statistics, topology, geographic coordinates, and geometry of objects. And in this case, the source of big data is the geographic information systems. Next is crowdsourcing. It is a method to collect data from a large number of sources. Next is predictive modeling, a set of methods used to create mathematical models in order to forecast predetermined probable scenarios and their outcomes. It can be also used to analyze a CRM system's database to identify possible factors that could eventually push subscribers to change the providers. Then data visualization, which is a method that aims to geographically present the results of big data analysis in the form of diagrams or animated illustrations to facilitate their interpretation. Then classification, a set of methods that can predict consumer behavior in a segment of a particular market. This is also used in data mining. Then simulation, modeling the behavior of a complex system is often used to predict and develop various planning scenarios. Then next is the supervised learning. It is a set of methods based on self-learning technologies that can identify functional connectivity in an analyzed data set. And unsupervised learning, which is a set of methods based on machine learning technologies used to identify the functional connectivity hidden in the analyzed data sets. Then we also have the machine learning, a discipline in computer science, formerly called artificial intelligence, aiming to create self-learning algorithms by exploiting experimental data analysis. Then next is optimization, where the set of digital methods used to redesign the complex systems and processes in order to improve one or more elements. This method is used to make strategic decisions such as investment analysis or selecting a product range composition to be introduced on the market, and the regression, where set of statistical methods used to identify patterns between the iterations of a dependent variable and one or more independent variables. And this method is often used to forecast and predict outcomes and also used in data mining. So these are the various big data analysis methods which we can use for various purposes as mentioned. It is very important to understand how farmers interpret the value of technology in the context of their farm. Farmers look at value to their overall farming business in adoption of the usage of big data, um, sensor platforms, and machine learning. And also, we can consider whether it poses a risk to their animals and their role as a good stockman by creating a physical distance between the two. The animal farming industry is quickly becoming a hotspot for new technologies such as deep learning, AI, and ML. These smart farming technologies are being used to monitor animals, predict diseases, optimize food intake, and improve animal health. But these advancements also generate massive amounts of data, and this data fuel machine learning algorithms to solve future problems. But this has drawbacks too. For example, it uses the data um, that use of this data is itself a problem. Vast amounts of data from the technology products and services get stored in remote cloud servers, and this is often monetized for commercial benefits. Big corporations collect, use, and even sell farmers' data, and farmers are already getting into tussles over this with big corporations. This rising tension over data misuse is a considerable threat. So, technology companies need to come up with better solutions to prevent misuse of their user data. Second problem may be there are a few instances where technology cannot be used effectively. In some cases, farmers are either reluctant or may not be able to use the latest technology in their farms. The access to internet and usage in the global food security strategy countries ranges between 10% to 50% of the population and remains a bottleneck for the adoption of the digital farming technologies, and only about 25% of the mobile phone owners of the global food security strategic countries by the animal product producers and farming household access information about agriculture and uses tools for livestock or animal production management systems through mobile apps and other means. There may be several other cases where technology cannot be used effectively due to various environmental, physical, and situational constraints. The successful companies of tomorrow will have to come up with innovative workarounds around these constraints. There are different challenges also. So currently, the available commercial sensors are vastly limited for reliable prediction and disease management of livestock farming through continuous automated real-time monitoring. For example, there are no sensors available to measure biomarkers from the breathing space of the cows and pigs, which could point out the gut microbiota or even the metabolic states of the animals. Additionally, there are specific technical challenges such as where the sensor will be positioned, what the sampling rate will be, and how the data will be transmitted, among others. And all these considerations have an impact on the accuracy of algorithms as well as the scalability and the practicality of the solution that could therefore be utilized on animal farm. And evaluating the sensor position, sampling frequency, sensor data analysis, and window size for the processing of data would help significantly to enhance the prediction of the farm animal behavior. So finally, the conclusion, the emergence of agriculture 4.0 is fueling the growth of adoption of sensing technologies, big data, and machine learning in modern animal farming. In the reality of pandemic scenarios where restrictions are making it difficult for veterinarians, nutritionists, and producers to visit the farms and feed mills, real-time 24 by 7 insights into the livestock's activity, consumption, and production are needed. So these insights enabled by sensing technologies generate data which are accessed remotely, resulting in lower costs and enhanced performance, responding to the demands of the consumer. So the AI ML algorithms have developed so fast. There is a lack of standardization in the collection and sharing of data globally, where more farms get connected to technology, and AI and sensing technologies will start playing a more decisive role in helping farmers see patterns and solutions to pressing problems in the modern animal farming. So while there are still several unknowns, limitations, and open-ended questions, so one thing is certain, that is, in this decade, we'll discover the true power of human artificial intelligence collaborations in the livestock sector. So these are the various references where I have used to prepare this presentation and tell about this presentation. So I would like to thank all the papers which I have referred, all the figures which I have taken from the internet for making this presentation very useful. So thank you so much for giving me the opportunity um, to act as a resource person. For any queries regarding this presentation, you can contact me on the mail ID hodudicit@mgmu.ac.in or hodit@jnec.ac.in. Thank you once again. Thank you so much.